Hello again, and welcome to our third module in our Introduction to Doka for DPUs DLI course, where we'll cover setting up a BlueField-2 DPU. Now that we've covered quite a bit about what Doka is and got into some depth about BlueField DPU capabilities, we're going to take this module to walk through the process of bringing up a BlueField DPU using SDK Manager and a manual install package to prepare you for using DPUs in your own labs and environments.
This module has three main sections. First, we'll describe a little bit about the installation process and your options for getting a BlueField set up and installed with the Doka SDK. Next, we'll walk through the installation process using the SDK Manager graphical user interface. Then, we'll also step through the process of manually installing a BlueField image and Doka SDK packages for hosts that only use a command line interface. Starting with the overview. There are many different ways to set up and install a BlueField-2. Some methods are easier than others, but with the release of Doka software packaging, it helps make things a little bit easier. For simplicity, we'll focus on two main methods or workflows that should cover nearly all use cases and skill levels in this module. These additional and more advanced installation methods will be covered in a different BlueField Deep Dive course, but be aware that it's possible to network boot with Pixie. You can create your own custom BlueField images to deploy. You can perform these manual installation and package installs using orchestration frameworks like Ansible or SaltStack. And we have some BlueField models that have a BMC to completely remove dependencies on the host for bootstrapping and installing DPU software. The SDK Manager workflows are by far the easiest installation methods. These workflows do require a live internet connection to be successful, so it's important to also discuss the manual installation method, and we'll step through examples of both. No matter what the installation method that's used, whether it's the SDK Manager or a manual install, under the hood, these are the high-level steps that are occurring. First, and the step that we're taking for granted here, is to physically install the DPU into a PCIe slot in the system and auxiliary power. After that, we start the Doka and BlueField software installation on the host side. With the Doka SDK packages, all of the necessary drivers, tools, and utilities are included and are installed using standard Linux package management software. After the host software is installed, we can move on to the DPU. There are workflows to upgrade the operating system and Doka SDK software packages, but for first-time use and to ensure a clean and trouble-free software environment, it's generally easier to simply install from a new system image, especially for the first time or fresh-from-box installation. As we've discussed, the system image contains all of the necessary Doka software and drivers to reduce all of the complexity of a piecemeal OS and then package install on the DPU itself. The final step after imaging or upgrading the DPU is to perform a firmware update and reset if applicable. Quick note about BlueField system images. They're called BFBs, and that stands for BlueField Bootstream. Conceptually, it's just a system image, although technically it's more than just an ISO. It contains a host OS, bootloader, and all of the necessary Doka software packages to make for a one-step Doka SDK install to the card. There are methods to allow for building a custom BFB image, so it would be possible to include an orchestration agent and configurations such as SaltStack to start without intervention to further orchestrate and configure a DPU after imaging. One of the most important software components for bringing up and installing a DPU is the RSHIM interface. RSHIM describes software and drivers that sit on both sides, the host and the DPU. Together, they provide a means to connect to and manage the DPU. We'll use many of RSHIM's functions in the manual installation procedure. SDK Manager workflows also leverage RSHIM, but do a nice job of removing that complexity and isn't something that would be noticed. RShim provides several key management functions. It can do things like reset the DPU, boot the ARM cores, and provide debugging by querying the state of registers, among many other things. Key to installation, RShim also provides a serial console connection and a TCP/IP network device between the DPU and the host. Revisiting a stack diagram from our previous module, we now have a little more context for those blocks in the middle. We can see the RShim components and see that things like MFT, the Mellanox firmware tools, and other diagnostic tools leverage this RShim interface. Zoomed in a little bit more on the management RShim interface, the sysfs has multiple files provided by the driver to control low-level functions of the DPU. An important feature is the network interface that's stacked on top. A network interface is provided by RShim to the host and allows you to access IP features and services from the host to the Bluefield DPU over a standard network interface. These management options can be restricted and disabled for use cases where isolation is required between the two administrative domains. We discussed this in our previous module about separated mode, embedded mode, and restricted mode. Restricted mode significantly limits what's exposed and what can be changed or written to in the sysfs, among many other things, to provide a secure isolation from the host. Here's an example of using the RShim network interface. We'll see this used in our upcoming examples. On the left is the host, and notice that with LSPCI, we can see two Mellanox Ethernet controllers from the Bluefield. After installing the RShim driver, which is included as part of the Doka meta package install or can be installed separately, notice that the host now has a network interface named TM/FIFO-NET0. By assigning an IP address of 192.168.100.1, we're able to SSH in to manage the Bluefield from the host. On the right, this is what the Bluefield OS looks like after installing the Doka BFB system image. Remember that all of the required Doka and Bluefield software comes packaged with the Bluefield system image. Again, we call that a BFB. We can also do an LSPCI here and see more devices. Notice that on the Bluefield card side, we also have a TM/FIFO-NET0 interface. On the DPU, RShim comes pre-packaged and pre-configured with an IP address and allows for IP reachability into the Bluefield from the host out of band from the physical network devices. Taking a quick look at the important connections on a DPU, we have first and most importantly the network ports. They provide the high-speed access for both the DPU and the host. The ARM management port is a 1 gigabit copper connection and is intended to be used for DPU out-of-band management access and other low-bandwidth infrastructure and network services for the DPU itself. The PCIe connection provides the high-speed system bus connection as well as power. The UART and mini USB port are both special ports that are enabled and supported by the RShim driver. Typically, these UART and mini USB RShim interfaces are not used in favor of using the PCIe bus for the RShim management access and tools. Looking at this diagram a little differently, by management access, there are really two main paths. As we pointed out on the previous slide, the OOB-NET0 interface is a 1 gigabit copper interface, and this interface is not exposed to the host. It is designed for only Bluefield management and system maintenance. Secondly, that TM/FIFO-NET0 interface is again provided by the RShim driver. Whether it's over UART, USB, or PCIe, this is presented and can be used like any other network device to access the Bluefield from the host or from the other side of the cable. This is conceptually like having a network cable between the two devices for any standard IP traffic and applications to use, but it rides over either the UART, USB, or PCIe connection. Again, PCIe favored because of its simplicity. Now that we've talked a little bit about the components and management interfaces, let's step through the easier method for installation and bring-up using SDK Manager on Ubuntu Desktop to set up a newly installed DPU. SDK Manager installation starts by installing the SDK Manager software. From the SDK Manager download page, click on the button to download the software installation for your operating system. If not logged in, you'll be redirected to the login page to log into the NVIDIA Developer Zone. With the installation file downloaded to your host, open a terminal window and locate the install file. Then, using your operating system's manual package installer, install the package. In our example here, we're using Ubuntu, so we'll use dpackage-i in the name of the file. Now, start the SDK Manager application from the CLI by issuing the command SDK Manager. The first step will require you to log into the NVIDIA Developer Zone so that SDK Manager can download the necessary files to bring up Doka on your DPU. Skipping ahead, after signing in with the browser for SDK Manager, accept the privacy notice to complete the login process. You'll be presented with the SDK Manager installation workflow. For our install, we'll want to make sure that we select Doka from the product category, then confirm that the hardware configuration is selected for both the host and the target, our DPU. The latest SDK version should automatically be selected, but take this step to confirm. Once those selections are ready, go ahead and proceed to Step 2. At Step 2, you'll see the overview of the host and target DPU installation items and packages that the SDK Manager will handle for us. Options to deselect or include individual components can be managed here. Once you're ready, click the checkbox to accept the terms and conditions of the license agreement and click to continue to Step 3. If the download folders and target hardware image folders do not exist, you'll be prompted to create them. After creation, continue to Step 3. Next, you'll be asked to provide your sudo password, since many of these installation tasks require administrative access. Now, the installation process will begin on the host first. This step takes several minutes, and once the Bluefield system image is downloaded and prepared on the host, you'll be prompted to provide a password for the default Ubuntu user. After that's entered, go ahead and click Flash to begin imaging the DPU and continue the process. After the imaging process is complete, SDK Manager will present a dialog box to log into the Bluefield to complete the Doka SDK installation. The default IP address is 192.168.100.2, and it's pre-configured on the DPU and should not require a change. Provide your default Ubuntu user password and click to continue the last part of the installation. Once the installation is complete, click Finish and Exit to close SDK Manager. If we bring up a terminal now, we'll see that we have our rshim TM FIFO Net 0 interface present and configured with an IP address, and we can log into the DPU by opening an SSH connection to the DPU at 192.168.100.2. Don't forget to log in as user Ubuntu if that isn't your current username on the host. Now we can see that we're on the DPU and can confirm versions. This concludes the SDK Manager installation process. The SDK Manager graphical user interface is by far the easiest route to setting up your Docker Bluefield environment, but some circumstances cannot accommodate the automated and live download method using SDK Manager. For air-gapped environments or locations with limited or metered bandwidth or internet access, there's a series of steps to install Docker from downloaded files. Let's walk through that manual process of installing Docker 1.1 on a Bluefield 2 DPU. The manual installation procedure starts on the host where the Bluefield is installed. Several files must be downloaded from the developer zone and staged on the host. The minimum set of files that we'll need are the Bluefield BFB system image and the Docker meta package installer. These files can be found on the Docker DevZone documentation at docs.nvidia.com/docker/SDK. On the installation guide page, under the manual Bluefield image installation, you'll see the list of links and files to accommodate support for different OS versions and for upgrading from previous versions of Docker for Bluefield. In our example, our host is running Ubuntu 20.04. So we'll need the host meta package file for Ubuntu 20.04 and the Bluefield OS system image, or BFB, which, as we've discussed, comes preloaded and pre-installed with our Docker SDK software. With those files staged on the host, the first step is to install the Docker meta packages. For Ubuntu, we'll use dpackage-i and then the name of the file to install. For CentOS hosts, there are some additional package installs and package manager configuration required before manually installing the Docker meta packages using RPM instead of dpackage, and you can find those few additional steps in the installation guide. Now with the meta packages installed, we can run an apt update. And we'll use our package manager to install Docker SDK, Docker Runtime, and Docker Tools to our system. With Ubuntu, we'll use apt, but for CentOS, yum is used instead. This step takes several minutes to complete. After the Docker SDK package installations, you'll want to optionally move your DPU to Ethernet mode if you have a VPI Bluefield model and wish to operate in Ethernet mode. Ethernet-only DPUs can skip this step. To check, start the MST tool and then run MST status to get the device name. If there are multiple entries, reference the PCI index here. Against the LSPCI tool using grep to search that output for Mellanox. Now, using the Mellanox config tool, we can check to see if we need to change our Bluefield to Ethernet mode. This command is located in the installation guide. In our case, that option isn't present, so we know we have an Ethernet-only DPU and do not need to make any changes. The Doka package installs take care of installing all of the software for Doka into the correct places, and includes, importantly, that rshim driver that we spoke about earlier. Notice that with the Doka packages all installed, we now have the TM-FIFO Net 0 interface present on our host. If we wish to access the DPU from the host over this interface, it will need an IP address. To permanently add a static IP address to the TM-FIFO Net 0 interface, we'll want to add a static configuration to netplan for Ubuntu, and for CentOS, add a specific network config script in etc sysconfig network scripts for this interface. More specific instructions are in the installation guide. For single use, the ipadder add command can be used to add 192.168.100.1/24 to the TM-FIFO Net 0 interface. At this stage, our host side configuration is complete. Next, we'll image the Bluefield DPU. To get started, it is recommended to create a password for the default username Ubuntu. Because password checking occurs by comparing a hashed version of the password, we need to use OpenSSL to generate that password hash that we'll set as our password during install. The command we need to use is OpenSSL password-1, and it will provide an interactive prompt to enter and confirm your desired password. OpenSSL will output a hashed string. We need to copy that string and create a file with a single variable in it with our password hash as the value. Using a text editor, create a file. I'll call it bf.cfg, and it must contain the variable with the exact string Ubuntu _password, and then our hashed password string. This is the standard bash variable assignment syntax. Save the file and quit the text editor. Now we're ready to image the Bluefield with the BFB install script. We need to invoke the script with a few arguments. First, --rshim, and then the name of the rshim interface for the DPU. In nearly all cases with a single DPU installed, that string will be rshim0. The next argument is --bfb, and this is where we provide the path to the BFB file that we downloaded and staged on this server. The last option is --config, and that will point to the bf.cfg file that contains our variable to set the Ubuntu password. The system imaging process takes a few minutes to complete. While the script is running and the system is imaging, we can attach to the rshim console to watch the progress more closely. Minicom or screen can be used. I'll use Minicom and pass in the console device as an argument. Now that the imaging is complete, we could simply use the rshim console connection here to log in, but let's SSH from the host over the TM-FIFO Net 0 rshim network device to log into our DPU. Again, with the default username Ubuntu and the password we provided OpenSSL to generate the hash in the config file. The last step after imaging to set up the Bluefield is to check for a firmware upgrade. Run the Mellanox firmware updater script located in the path shown here. It will query the hardware and check if a firmware update is required. In our case, our firmware is up to date. If you do perform a firmware upgrade, ensure that you follow the additional step to perform a firmware reset after any firmware upgrade takes place. That process can also be found in our Doka SDK DevZone documentation under Firmware Upgrade. This concludes the manual setup steps to have your DPU and host set up correctly with the Doka SDK. At this stage, we can launch one of the included sample applications, such as the URL filtering sample app. If we browse to opt, Mellanox, Doka, examples, URL filter, and then the bin directory, we'll see the URL filter sample application. With a few runtime prerequisites listed in the instructions for the sample application documentation, we can launch the Doka URL filter and know that our system is set up and configured correctly to run Doka applications. In this module, we covered a few of the main methods to installing and setting up a Bluefield 2 DPU. There are more ways than this, but the SDK Manager and manual methods should cover nearly all beginner and getting started use cases. We also covered some of what occurs under the hood with the installations, and some of the helper software such as rshim that helps us perform these setup and installation steps. Thanks again for joining us, and we'll see you in the next module.